Hello. I hope you are doing well. I am doing great. Thanks for asking. So in this video, we are going to create our very own version of dplyr select. So for start, let's check what exactly does dplyr select do. So I'm just going to fire up my R session and then let's do dplyr select. And my machine is taking a second or two because I'm recording, but here we are. So select is used to keep or drop columns using their names and types. For this video, our focus will only be on the keeping of those columns using their names. It's going to be an introduction to metaprogramming in R. So if you haven't done any metaprogramming before, then this is the video for you. First, let's depict or show what we are going to achieve in this video. You see how with dplyr select, you can just take iris. So we take iris and then we pass it to dplyr select. And then for the column names, we just like drop them in. So sepal.length, then petal.width, if I can get that right. And then maybe species. And let's take the first few observations. The main point of focus should be on how we pass in these column names. For sepal length and petal width, we haven't put any quotes around them. But for species, we have, and everything just works. That is going to be like the function that we want to create. Our own version of select, which when given unquoted variable names, just works, right? Yes, let's get started. So the first thing, of course, is to create some sort of a folder which holds this. This is just like a mini project. I don't have to do this. It's just that I am used to this way of doing things. So I'm just going to do make dir and then let's call the folder select. I am totally out of names. So let's cd into select. Now we are inside of that folder and let's create a file where we'll write the code. So let's call it select.r. So creative. So now we have the folder, we have the file. The next thing is to open this in your favorite editor. You can go for Positron, RStudio, VS Code, Sublime Text, whichever works for you. For me, it's always NeoVim, by the way. So let's actually, before that, I'll need to split my terminal. You don't have to worry about this part. So I'm going to do tmax new session and let's just call it select. And then I am going to open that folder in NeoVim. So I am now inside of select.r. Let's print a hello world. Just a habit, I guess. And then let's run it. So r script select.r, and there we go. We have a, we have a hello world. To start off, we already know the function name that we want to create, right? So the function name is supposed to be select. So we are going to start with select. Select will be a function. We don't yet know the parameters, so I'm just going to leave it at that. And let's check what dplyr select does. So let's just create a new window here and fire up an R session and check what does dplyr select take as arguments. Again, taking a second or two, but here we are. So if we scroll down just a bit to the usage section, you can see that select is a function which takes two arguments. The first one is the .data, of course, that's the data frame, and the second one is the dots, which are now one or more unquoted expressions separated by commas. For us, we are going to assume that whatever expression is passed to our function is basically a column name that we are going to subset. That will be like a very good intro. So we go back to the function and then we provide it with the arguments. So the first one is .data and the second one dot. Now let's get into the function itself. The naive approach would be to just do .data and then subset dot, and we would expect this to work in some cases and fail in others. For example, if we just take iris, if I can get that right, iris, and then we pass it to select, and we say species, for example, let's take the first few observations, right? Then let's do r script select.r. You see, we get the first few observations, totally fine. Actually, let's add the drop equals false so that it's always a data frame. So drop, setting drop to false, so that now if we run this again, r script select.r, we get a data frame, and that's totally fine. So our select kind of works. But now you see, if we add another variable here, actually still quoted, if we add another variable, let's say sepal dot width, okay, sepal dot width, if we add it there and we try to run the selection again, you see we get an error, unused argument sepal width. That's because the G argument of the subsetting, like the square subsetting operator, expects a character vector, and what we have passed, I think it will take the first, the species will be taken as the G argument, but then the sepal length will not be used anywhere when subsetting, so it is the extra argument. What we can do to make this work is maybe wrap it in a character, to make it a character vector. So we just wrap it in C, and if we now try this again, r script select.r, it actually works. But you see, that's not our end goal. Our end goal is to not have to quote any of this. Like, it's not to just have iris, then we pass it to select, and we just, you know, do sepal width and then petal dot length, and maybe species. We'll deal with the species case in a bit. For now, this is our ideal use case. Let's just go into the function again and think, what is the first thing that we need to do when we just enter into that function, or when this function is called? It is capturing the function call. As simple as that. The very first thing that you need to do is to capture the function call before any of the arguments are evaluated. Because once those arguments are evaluated, then R will throw the errors of sepal.width or petal.length not found, because in our scope, we do not have a variable called sepal.width. For example, if we just say, like, okay, let's just run it the way it is and see what happens. So if you say r script select.r, you see we get object petal length not found, and that's like true because we don't have petal length defined anywhere in our scope. So the first thing when you get into this function is to capture the function call itself and evaluate, like, how the function was called, the function name, all the arguments before any evaluation. So before evaluation, our arguments are usually promises, not the JavaScript type, but they are another type of like promises in R. So we are going to do match.call, and before we run it, let's first of all check what does match.call do. So we come here, we fire up an R session, and we check match.call. Match.call returns a call in which all the specified arguments are specified by their full names. That means when we do this call, the highlighted line, when we do this call, match.call will return the function name that we called, all the arguments with their names. So for example, if we said .data equals to something, then it will be named. That should already give you an idea of the type of call. So, but actually, let's throw in a browser right here, and let's source that file so that, like, the browser is a debugger, and when we run this file, it will take me exactly to that line. So let's source select.r, and here we are. If we check call, you can see that we called select, and then we passed in .data as iris, and then some other arguments were sepal.width and petal.length. Totally fine. Now let's check, let us check the length of call. So if we do the length of call, it has length 4, but wait, why is that? That's cool. Okay. We passed in like 3 arguments, but apparently the length of this call is 4. And that is because the very first item of call is the function name itself. So the way this call is structured, it's in a list like format. So you can just do call and then, well, a named list to mention. So you can just do call and then subset 1. And since the first item is like the function call, if we run this, not the function name, I mean. So if you run this, you can see that that gives you select. But now let's check the names of call. So if you check the names of call, you can see the first one is just an empty string. The second one, .data. The third one and the fourth one, those are also empty strings. Now, we already know that the first one, of course, should be the function name. The second one, it's already named. We know that that is .data. But this third and fourth ones are now like taking the place of dots, or rather part of those dots. What we need to do, however, is to capture all the dots in under one item, right? First of all, let's check match.arg again. So I'm going to quit the browser and then let's check the docs for not match.arg, match.call. And we can see that there is an argument called expand dots, which is by default true. Now, if we just scroll a little bit to the explanation, expand dots, it's a logical and should arguments matching the dots in the call be included or left as a argument. We want the second case. So we go back to our code and we change expand dots, we set that to false. Now let's source that file again so that we can inspect the call. So let's do source select.r. Here we are. Now if we check the call, or rather call will still be the same, but our interest now is the names. So the names of call, we have the first one empty, but we already know what that is. That is the function name, and we are not interested in that. The second one is .data. We aren't really interested in these two, but nice to know. Now, the third one are the dots, the ellipses, and this is our main interest. What we'll do now is go back to the function and subset the dots themselves. So subset ... and then let's rename call to dots. Yes, I think that is like a good start. Now let's actually resource the file again and see what dots have. So let's do source and then select.r. Now let's see the dots. You can see that dots, it's kind of a list. Actually, let's check what is the class of dots. Should be a list, I guess. Well, a pair list. So it's a pair list and it has 2 elements. It's of length 2. The first one, you can see that the first item is like the sepal width. The second item is the petal length. Now, what is the class of sepal width at this point or petal length? Remember, these are just unevaluated expressions. And let's actually check their class. So we do dots. Let's start with the first one. And so dots subset the first item, and then let's check the class. So that sepal width at this point, it is a name. So you can think of a name as just an unevaluated expression. Next, let's look at petal length, and we expect that to be the same. So dots subset the second element, class, this should still be name. Totally fine. Now, the next thing should be, we don't want to evaluate them. We don't want to evaluate sepal width or petal length. What we need to do is to convert them to characters. So take this unevaluated expression and just convert it to a character string, so that now I can do the subsetting using the square brackets, right? Let's check another function in R called dparse. So we are just going to do a question mark dparse. Dparse turns unevaluated expressions into character strings. Like you get what is advertised. When you give it an unevaluated expression, dparse will give you back a character string. That means, so we go back to the function. Since dots, remember that dots is a pair list, so we can treat a pair list as a list, just like a normal list for now. Since it's a list, it means for every to dparse each of its argument, we have to like do some sort of looping. Let's just go with lapply. So we are going to do lapply to dots, and the function is going to be dparse, right? And then, since the result of this lapply is going to be the like whatever is in dots, we have now converted it to character strings, right? So if sepal width was an unevaluated expression, it is now a character string. And that character string is actually one of the columns that we want. So we are just going to assign this to calls, and let's pass the lapply to unlist, so that at the end of the day, we get a character vector. Like calls, after the unlisting, calls will be a character vector. And then we pass the calls to as the G argument, as the G argument of the square brackets. So the normal subsetting, like dot data, and then I want you to subset these columns. Of course, drop equals false. This should actually work for this test case. Let's give it a spin run. If we just do R script select.R, and there you go, it actually makes the selections. And to confirm that, maybe let's add a new one, species, and right, let's do R script select.R. There we go. So it's actually working. But what happens if we put quotes around species, right? What happens if we put quotes around species and then try to run it again? Now we have a problem. It says undefined columns selected. That already gives us a hint of where the error might be. Initially, when we weren't putting any quotes, like when we just had petal length and sepal width, we didn't have any problems. But now after introducing the quoted species, we have a problem. So that means we need to check what exactly does calls have when some of the arguments have quotes around them. Let's throw in a browser right there, and let's source this file again. So source select.r. Now let's check calls. You can see that calls has a value like sepal width, totally fine, it's now quoted. Petal length, totally fine, it's now quoted. But the species has double quotes, and that is because dparse doesn't try to evaluate any of those arguments. Like regardless of whether the incoming argument is a character or not, it doesn't care. It just, adds the extra quotes. You can think of that, you can think of it that way for now. Just tries as much as possible to convert, or rather to force whatever you have given it to a character string. That means in our case, what we actually need to do is to dparse conditionally, as in when you find that the given argument is a character vector, no, a character string, then that's totally fine. Do not do anything to it. But if the given argument is not a character, it's not a character string, uh, then you can go ahead and force it to be a character. So let's do that. We are going to define a small function here called toChar, and it's going to be a function of x. And what it does is just checking if is character x, then I don't want you to do I don't want you to do anything. I just want you to return x. Otherwise, I want you to depass that x, like force that expression to be a character vector or a character string. Now, after defining toChar, that is the function that we want to apply to dots. So the function now is going to be toChar, and remove the browser call, and everything now should work as expected. Let's see. So we have select. It's a function which takes dot data and dots. Then we capture the dots here, and then we are setting the expand dots to false so that we can be able to subset using like that, so that we can be able to subset the dots by their name, which is dot. And then we define a function to depass an expression conditionally. So we just check, is that expression already is it a character vector, like, or a character string? If so, just return it as is, do nothing. But if we find that that expression is not a character vector, it's something else, then I want you to depass it. Now we apply that function across all elements of dots, and then we unlist so that we get a character vector. And then at the end of the day, we still use the normal subsetting square brackets, then passing in the calls for the G argument and setting drop equals to false, so that in case it's just one column that's being subsetted, it is not coerced into an atomic vector. And yeah, this should work. Let's source that file. So let's quit the interactive R session and just do R script, select.r, and there you go. It's working. Maybe what else can we add to this? Let's try removing these quotes around species. Should still work. Let's test what if we just give it a single column. What happens? So if we give it sepal width alone, and that's working as expected. So that is how you can define your own select version of dplyr, right? Using bizarre alone. Maybe the main thing to take from this video would be the very first thing that you need to do if you want to capture the expressions before they are evaluated is to call match.call. So that gives you promises, and then you can program those promises however you wish. But once they are evaluated, then they are no longer promises. Yes, so that is it for this video. Thanks for watching. See you in the next one.